In this video, I want to look at solving a linear system that contains three equations and three variables. And there are a few ways to attack these types of problems. But in this specific example, I want to go ahead and look at solving this linear system by using substitution as our first step. So in order to facilitate substitution, I'm looking for one of these variables whose coefficient is either 1 or -1. And it looks like this t variable in our first equation will do the trick. So t will be easy to isolate. It's a negative t, so I'm going to move it over to the right side and make it a positive t. And then this positive 20 I'll move to the left side to make a negative 20. So this first equation becomes negative 3r minus 6s minus 20 equals t. So now I have this expression that's equivalent to t. So what I'm going to do is plug it into the t in the second and third equations. So both of them. So let's go ahead and do that. So I'll start over here with the second equation. Negative 5r minus 2s minus 4 times t. Of course, when I use substitution, we will always use parentheses. And then that equals 0 for the second equation. Let's go ahead and simplify this down a bit before we move on to the third equation. So negative 5r minus 2s. And this negative 4 will be distributed here. So I'll have a positive 12r, a positive 24s, and a positive 80 equals 0. Let's go ahead and write this in a standard form where I have r and an s, the variables, on the left side with our constant on the right side. So negative 5r and positive 12r will make 7r, and negative 2s and 24s will make positive 22s, and that's going to equal a negative 80. I'm going to go ahead and put a box around that because he is an important equation. So I got him by taking my expression that was equivalent to t, and I plugged it into the second equation. Let's go ahead and do the same thing but with the third equation. So that third equation is a negative 5r plus 5s plus 3 times t. And of course t is this expression, negative 3r minus 6s minus 20. And that's going to equal 7. So just like we did with the second equation, let's go ahead and simplify this a bit. So negative 5r plus 5s. And I'm going to distribute this positive 3 through here. So negative 9r minus 18s minus 60 equals 7. So once again, I can put the r's together, so negative 14r. I can put the s's together, so 5 minus 18 is negative 13s. And then I'm going to add 60 to both sides to get these constants together, so 67. Okay, so here we have two major equations. And both of these equations I arrived at by substituting my expression for t in the other two equations. So what it looks like I have here is an equation with r and an s and a constant, and r and an s and a constant. So I started with the system of equations, three equations with three variables, and I've kind of whittled that down to a system with two equations and two variables. So let's go ahead and stack these. 7r plus 22s equals negative 80. And the second is negative 14r minus 13s equals 67. And at this point, probably elimination is your best bet because all of these variables have coefficients other than 1 or negative 1. And particularly because when I look at the r, I have a 7 and a negative 14. So I just need to multiply this top equation by 2. So I will multiply 2 by every term, and the r's will be a positive 14 and a negative 14 for their coefficients, which will make them cancel or eliminate. So let's run that 2 through the first equation. So 14r plus 44s equals negative 160. And the second equation is left unchanged. So when I add those, my r's cancel, and again that's by design. So 44s minus 13s looks like a 31s, and that looks like it's going to be a negative 93 whenever I take a negative 160 and add 67. So a quick division tells me that S is going to be -3. Well, all right, so now that I know that S is -3, it looks like I can plug that into either of these two equations, and I can get the value of R. So let's go ahead and do that in the first equation. So 7R plus 22, and my value of S was -3, and that equals -80. So 7R minus 66 equals -80. When I add 66 to both sides, 7R is going to equal -14. So a quick division by 7 yields an R value of -2. Okay, well now that I have two of my three values, let's go ahead and plug them back in, put them together, back into the equation here where T was isolated, and I have it in terms of R and S because I have those values. So I'm going to go ahead and rewrite that. So -3R minus 6S minus 20 equals T. I wrote it down here at the bottom. So let's shuffle on back down. And now I have these two values. So -3 times R, well, R was -2, minus 6 times S, S is -3, minus 20 equals T. So 6 plus 18 minus 20 equals T. It looks like 24 minus 20 equals T. So the value of T will be 4. Okay, well we can almost see all these at once. So we have S, and we have R, and we have T, and we have all those values together. So let's write them as an ordered triplet, and that will be our solution. And we will always write them in alphabetical order, so it needs to be R, S, T. So R, S, T. So let's go ahead and get those values. R was -2, S was -3, and T was +4. And that will be the solution for this system with 3 equations and 3 unknown values. And I just want to do a quick recap. We got the solution by first using substitution. We saw that the first equation was easy to isolate T because the coefficient of T was a -1. So we just kind of swapped these two terms. The -T went to the right to become +T. The 20 came to the left to become -20. And once I had that expression, I needed to substitute them into both of the other two equations for T. And what that did is gave me 2 equations with 2 unknowns. So it's kind of a process of whittling our equations down from 3 to 2, and then ultimately using elimination to get it down to 1, which is one of the values. And then I slowly just build it back up by finding the other values by doing some back substitution. So there's that example, and there's our ordered triplet, -2, -3, 4. That is the solution for that system.